confident you can get at this. And there's plenty of tools out there. Let me demonstrate a few things here. Bringing up this Wireshark FTP capture activity. I'm going to refresh because I have been updating it this morning. Let's see, it doesn't display well on this web page. But what I want you to do here in this lab, similar to the last one, I'm going to bring over the actual file here to make it easier to read. What we want to do, if you can, and you'll learn the most from this, you actually can set up an FTP server. I'm going to go quickly through how easy it is to set up an FTP server. Has anybody done that? Have you set up your own FTP server?
Yeah.
Pretty easy to do. Which one did you use?
I think it was that VS FTP.
Okay.
VS, whatever FTP. It was a while ago, but.
Let me show you how easy it is to set up FTP server for practice at this, because you learn the most by actually setting up your lab. So let's just show you how quick and easy it is. I go and look for FTP server, see if my favorite one is out there. What I use is FileZilla. See if that shows up as one of the first here. Boy, I'm kind of slow. You can set up your own server out there on the internet. There it is. FileZilla shows up as the first, almost the first non-ad, second non-ad link. I love FileZilla because it not only can set up a server, it actually can be a nice client as well. So you can download the FileZilla server and install it and run it as a server. Yeah.
So since you put this assignment under the same one as we did earlier in the week, are we just gonna add another submission or?
Yeah, we can just add the images that we capture from that. Okay. I didn't realize I had. Let me check. I think I may have actually had two listed there. Sorry for the confusion here. Get excited about activities. There's a Wireshark activity. Did I have two? FTP session capture and traffic analysis. Do I have those backwards? Just let's see what this one was. I might have. This is the whole capture session. Let me go back to that other one. The Wireshark FTP capture activity.
Yeah, that was the one that came up earlier.
Yeah, this is the one I meant. Yeah, let's build on this one because that last one was pretty much practice. We'll just build on this one.
We'll just add to the.
Yeah, we'll just add to our uploads for this. Okay, so here's a description of this. That if you want to do it the best way and learn the most, this, and we used to, originally this was all in the lab here, but now with the remote option, I've given you a capture file to work with. But while you start up FTP, and if you want to do the most challenging and learn the most, you can download this FTP server. And it's a fairly quick install. I'm gonna go ahead and store it there. Once it's down, you have this executable, and I'll show it in my folder. In the folder, there's your server, and fire that up. It will install it. Asks you to agree to the license. It installs FileZilla as a service. I don't need to see source code. I'll go with the default settings. And next, installs its default location. The port interface, standard ports. And it will actually start the server. Now you can do this in Windows. Fairly easy to do it in Ubuntu, Linux, and many other Linux versions as well. Typically, it's just a yum install on CentOS or Red Hat. apt install FTP server. There are multiple types, so it takes a little while to learn it. And here is my host. I can establish a password for administering it. I'm going to leave the password blank. It does have a port that it uses for administration. And then my server is running. because I'm behind a router here, it's only going to be an effective FTP server on our local network. But I can go to my server and administer it and set up the location of the files when I FTP files to and from it. I can create users in my server. I can establish the message, FileZilla server, University of Duke lab. So I can see it remembers past settings and has basically done an update. I can have various filters applied, apply other settings, and at some level here there are users that I can specify. So lots of options there, but you have a decent and fairly secure, well, FTP is not secure, but you have a decent FTP server running. So if you ever need to quickly configure and test FTP services, FileZilla is a great one. But remember, it is not secure. If you ever want to do real file transfer, here's the one I highly recommend, at least for Windows, WinSCP. This is a secure FTP. I think FileZilla will let you run secure FTP, but WinSCP is a secure FTP client. Not as exciting to do captures because everything is encrypted and it's tougher to work with. So we're basically working with insecure FTP just to give us practice at getting at data from files. So with this FTP server running, I can transfer files to it and from it. But remember, if I'm doing capture, when you're running Wireshark, and I have Wireshark sitting over here, when I'm doing Wireshark capture, Wireshark, remember, it's running on your local machine. And so it's only able to see traffic from your machine to everywhere else on the internet. So if I'm a network administrator and I want to capture and analyze traffic, say FTP traffic, what would I do if I want to see everyone else's traffic? What do I need to do?
Put yourself higher up the chain. Get yourself on a router level.
Yeah. So if you want, I'll just make quick notes with this. If you want to capture your network traffic and secure your network, or do forensics on your network, here are your options. You need access to the firewall and then run whatever capturing you do on your firewall. So you could capture firewall traffic. That would mean you'd have to figure out how to do this on a, say, a pfSense machine, pfSense software, and do some sort of capture. The tricky thing about that is you're messing with your firewall that everyone else is using, and if you start capturing and saving file, that can put a heavy load on your firewall. You're able to see the traffic, you're installing packages on your firewall, but every package you add, remember how you added those packages to your pfSense? Every package you add is a load to that firewall. And you may actually do your own denial service. You may bring down your firewall. So this is dangerous to your network. You're going to be getting calls for why is the network so slow? Because they're capturing, and you can easily fill up your disk with those captures, because captures is a lot of data. Imagine someone's downloading a 10 gig file. Well, if you're capturing all that information, you've captured 10 gigs of packets, and that's just one of your users. So what you need is an appliance or an offline or a tap to view the traffic that's not getting in the way of your firewall. You need something that can watch all the traffic but not interfere with the traffic. And so it's dangerous it's effective, and you eventually will want to have some good software running on your firewall. But to actually view all the traffic, you need a way to have basically wiretap your network. Does anybody know how that is done? Let me demonstrate. You have a switch in your network, called a network switch. It is somewhere along the backbone of your network. So it is seeing, or it is passing all traffic through. On that network switch, you can set up a port to, guess what? Mirror all traffic. You can have your PC attached to a port on the switch that gives you a mirror of all the traffic. Normally, that's a very bad thing that your switch would want to do. You don't want to send all your traffic and repeat it out every port. That used to be how switches worked way back in the early days, back in 2000. 10 megabit networks, they actually called them repeaters. They weren't even called switches. They were called repeaters. Every packet that came in one port was repeated out all the other ports. People quickly realized as their networks grew that these repeaters were useful for letting everyone talk to each other, but they generated a lot of unnecessary traffic if the traffic only needed to go from port 1 to the destination PC that was out on port 16, instead of repeating it to ports 1 to 15. Switches had that ARP table. Remember the ARP table in switches? You have your MAC address, packet needs to go somewhere. Your switch only needs to send the packet out the port where that known MAC address destination is. Made it a little harder to sniff all the traffic. So they have that setting in there that you can configure a port to mirror all traffic. They call it, and some call it, promiscuous mode. Then that's where you attach your PC running Wireshark. You get to see, you're essentially setting up a wiretap. You're seeing all the traffic passing through that switch. Now you have to pick the right switch. If you pick one that's off on the branch of your network, you'll be watching just the traffic going and coming from that branch. You can pick the switch that is right on the inside of your firewall. The advantage of this, you are not loading the firewall. I have done this, and I have noticed the switch, the user interface to the switch does slow down. So it does affect your connection to the switch, because suddenly there's a ton more traffic that you're seeing on that port. But it doesn't bring down your network. If you mess with filtering and capturing on the firewall, you're going to slow down. I guarantee you're going to slow down your firewall, maybe even crash it, because they don't do that very often, and pfSense is not meant to be a traffic capture device. It's meant to work as a firewall. So unless you put in a very fast and big disk and you limit how long you're doing that capture, you don't do the capturing on the firewall, although you can. Remember that snort software. That's essentially, snort is helping you filter all that, but it's not capturing it. Remember, when you're capturing it, that's a lot of data. You need to store that if you're going to capture it. So, cool thing about this, once you have a switch set up, you don't need any other software except Wireshark and a nice large to this on a VM just for practice. And it wasn't a very fast blade server. That VM was suddenly locked up because it didn't have the power to do all the capture. So it will slow down or even crash your PC, but fortunately, you're just slowing down or crashing one PC that's not affecting the rest of your network. So back to our capture now. Let's get practice at doing this. And we'll come to read the instructions here, where we want to, first of all, take a look at the session. I'm going to go ahead and use this one just so those of you online remotely can work with existing captured data. I can always go to Wireshark whenever I feel like it, and I can start a new capture just by clicking. That's the I've opened a capture file. I can always go to Wireshark and start a new capture. Here I've opened up previous captures, but it's so easy to start Wireshark. And if you don't see your devices when you're starting up Wireshark, you may need to run as administrator. If you don't see your network interfaces here as soon as you start up Wireshark and what to capture on, then just right-click on Wireshark, right-click, run as administrator. If you don't see your devices. When I did the initial setup, I set it up to make sure non-administrators can capture. But if you're running as administrator, you will definitely, if everything is working right, you will see all your devices. And you only need to capture on a specific device. I'm not sure why I'm seeing traffic on my virtual host only network, because I didn't think I had any VMs running here. It's surprised about that. So I'm gonna, since I'm running as administrator right now, and I don't like to do that if I don't have to, I'm gonna stop that and come back and just run it as a normal user. Although I am an administrative user, I'd say I'm at a slightly less dangerous level, but remember, I am logged in as an administrative user. Choose your interface that you want to capture on, and then just start the capture. At this point is when you would quickly go over and do an FTP transfer to your FileZilla server, or you can always go and connect and via the client to a server, and you would also capture that traffic. Because remember, Wireshark is capturing traffic both going and coming. If you're the server yourself, you can FTP, and I think it will also show that traffic. Okay, since I already have the capture files, I'm going to pretend that I have logged into an FTP server, transferred a file, and now I'm going to come back and view the captured data. So I could stop under Wireshark. If you want to save the capture for later, you can just do save as, and you've captured your packets for later analysis. So pretend I've done this. I'm now going to open that file that I made available to you. I'm going to make sure I get the right file by going to that activity and clicking on this. Make sure I get exactly the right file. Downloading that one. And saving it to my 2020 fall. There's my net capture 191101, so it's from last year, and saved it. Because I have Wireshark installed, I can start Wireshark and go do a file open, or I can just double click on the file and it's automatically associated with Wireshark. So I double click on that, and now Wireshark, instead of going and capturing packets from the network, it simply shows me my capture file and how many packets I have here. 1329 packets. And when was it run? I have date and timestamps in here somewhere. And if I'm doing forensics, I will keep track of all of that. I have a time of the beginning of the capture. Do I have somewhere in here? I should have a universal time somewhere encoded. But I'm not worried about that right now. What I'm looking for is my FTP session. What's the quickest way to find my FTP session? In the filter?
Yeah.
There's FTP, and there's FTP-data. FTP will take me right to the FTP protocol. Another way to do it, if I don't remember that, I can just filter by protocol and then go find them alphabetically if I'm not sure what I'm looking for. So I can click protocol and then see FTP there, click on that, and then right click, follow that stream. So I like the display filter because that's really powerful. Just type FTP, turns green telling you, hey, that's a valid expression, and it takes you right to the FTP traffic. And I can right click, follow TCP stream, or Control-Alt-Shift-T, and I have my stream displayed in a window, showing you immediately the insecurity of FTP. Plain text passwords and usernames. I see some interesting information here. This has to do with transferring files. Here's the IP address of the file. This is actually the port it's going to use for the transfer. So there is a way to actually know what port is being used by multiplying that number by 256 and then adding this one. That'll give me the actual port used to do the transfer that comes later. But there's an easier way to get and extract the image that was sent in that stream. This one, let's see, what am I think I'm wanting a screenshot of that. Let's verify that. An upload, password in plain text. So we want a screenshot of that. So let's go ahead and capture that screenshot. By easiest way to do that is Control-Alt print screen.
Hey, Professor.
Yes.
Did we do this last time with the Wireshark?
We did this part.
We did this part already. Yeah.
Oh, okay.
So this is that part. Just giving you practice at this. One thing more about this is that number right there. That is the port. That you can use those numbers to figure out what port was actually going to be used to transfer. So 230 times 256 plus 178 is the actual port used to transfer the next file. Now we're going, and notice here, every time you do a transfer, the transfer of the data goes across a different port through your over the network. That's how FTP works. So getting a little more detail there. So Control-Alt print screen will give you this ready for upload. Now we're going to get into the little more details of this as we want to now capture, extract that file. So we're getting into a little bit of network forensics here. And this is how it's done with many types of data being sent using Wireshark. We're going to capture the FTP data, but before we do that, let's take a look at how we could see what else has been transferred across that capture. So this file you can save as an image to upload. Say I did a Control-Alt print screen. If I now start up Paint, I can come over here to Paint and do a paste, and then do a file save as, and I can save that then as a PNG here. I'll go ahead and put it in my CIS338. I'll do that. I'll make a new folder called Wireshark FTP, and I'll save that as plain text password display. Screenshot. Okay, so I've saved that screenshot as a little image. I could, if I liked the text and wanted to document it, I could select it and copy, paste it, or from here, I could do a save as, and it will save it as, let's see here, as ASCII file. See here, I can decide how to display that data. ASCII is the best way. Then when I save it, I can actually save that as a text file if I ever needed to go back and copy paste out of it. That's a nice thing about text. I can use that information. Otherwise, it's saved as an image, and I have to manually retype things if I wanted to capture them or do an OCR or something. So I'll call it FTP password text file. So I view the stream. I can save it in various formats. So depending on what stream you're viewing, this is very handy. If I'm viewing code or some interesting formatting, I can save this as a hex dump. If I'm not sure what the data is, but it's interesting, I want to store it for later or do some more forensics on it, I can decide what format to save it as. The next format we're going to use is raw format, the actual raw data. Now that text isn't useful as raw data. That's more useful as ASCII. But let's go find the stream that was sent. In this particular stream, I see that they had actually transferred this file called pumpkin.jpg, and they'd also sent a directory listing. That's not so interesting, but this pumpkin.jpg, can I see what that picture was? Can I extract that out of the stream? It is in the stream, and watch how easy that is to capture. So I can close this and then come back to my capture stream and close that filter, the display filter, by clicking the X over here. And now I want to look for other data. Let's find the data that was transferred. The easiest way is do, in my display filter, Ftp Data. Because remember, FTP uses a separate channel to transfer files, and it uses a different port. I click on that, and now I can right-click follow that FTP data stream. Now there's a clue here in the forensics. At the very top, I'm interpreting it ASCII. I see this. I've already told you back in the, well, I saw that back in the screenshot that I was transferring a JPEG file. As you get into forensics, you will start to recognize, and let's look at this as hex dump. You'll recognize when you get into forensics, the header of a data block often indicates what type of data that is. And you'll learn that with JPEG files, these magic numbers at the start of the data block tell me that this is a JPEG file. Even though I know it's a JPEG based on what I captured from my following the login and transfer, suppose I didn't have this. I just know that, hey, they transferred something. Maybe I didn't. Maybe I started capturing after they had logged in, and I don't know what was being transferred, or I only have part of the capture. Well, I see the FTP data from my forensic knowledge. I can know that, hey, this was a JPEG. Now, what if I want to actually see what this image is? If I do a save as here, I'm going to save the hex dump. That's not terribly useful. I have the data, but I want to be actually to see what image was transferred. In order to see the image that was transferred, I need to change my data save as right down here as raw. I still see the data, but now when I do a save as, I can now give it a file name, and I know that this is a JPEG file. I'm just going to save it. And actually, I know the name that they gave it. If I want, I could give it that same name, pumpkin1.jpg. But all I really need to do, knowing that it's JPEG, I'm just going to save it as image1.jpg. I tell Windows, hey, try to interpret that as JPEG. I think it's a JPEG. Let's go ahead and save it as a JPEG. And now do a save. It says it saved it. Now let's go browse over to where I saved it to. Where's my Wireshark capture? There it is, Wireshark FTP. There's my image1.jpg, and I can tell already from the thumbnail, hey, it does look like a valid JPEG. Double click on it, and it opens it up in the Photos app, and I see I have a valid JPEG file. Now, there may be secret data encoded in there. There's a way to actually encode secret messages in JPEG files. It's called this strange name, steganography. Maybe we'll do a little steganography lab. That would be a fun thing. You have to find special software you can hide data among the pixels of any image. If you know how the data was hidden, at the other end, you can extract that hidden data that's hidden inside of an innocent looking picture of a pumpkin. You can hide gobs of data into JPEG files. Yeah.
So what are you gonna want for screenshots of this bit?
This one, just upload the image that you pulled out of the data.
Okay.
So remember how that was done. Let's go through that process again. Remember how we did that. We did apply display filter, ftp-data. Then I chose a stream just by right-clicking follow stream. That showed me from the beginning of the data, and this is the way it works with a lot of data files. The header of the data file gives you some clues as what's in there. Now remember, I had a clue already that it was a JPEG being sent. But if I didn't see that, I would know based on seeing JFIF and viewing the hex dump. I know that a JPEG file starts with that I'll call it a magic number, or just a unique header. Then I do, after telling Wireshark how to save the data, then I just do a save as, and then give it the file name. I'll call this one image 2, even though it's going to be the same data. And then I'll know for sure that it's valid data when I go back and then view the data that was saved into my folder. Now I'm not sure why image 2 is not showing up. Did I do something wrong? Oh, I forgot to save it. I forgot to save it as raw. I saved it as image 2, but I forgot to change my save data as raw before I went and did my save as. Now I'm going to resave it as image 2, replacing that. Now, I thought, what did I do wrong? Now I go back to where the data was saved. And there I see image 2 has the valid data. So don't forget that last part. When I save it, tell it how to save it. Now let's take a look at a couple other practice streams. The more practice you can have at analyzing streams, the better you will be at this tool.
Is this the only one you want actually on the assignment though?
Yeah.
So as long as we have the password bit, then we just put
Yep.
the picture of the pumpkin and then we're done.
Yep.
All right.
I'm going to look at these other ones because in Wireshark, there's other great ways to actually capture data out of it. So if I had other data here, say I have a capture, I've captured for an hour, huge file, and I want to analyze what was transferred during that hour. And you could actually do that now and visit some websites and then go back and view the stream. I can go underneath File and go to Export Objects and click HTTP and see if there were interesting objects that Wireshark will already have identified for me. And I see in this packet session, there was this object. Not sure what that is, but it is identified as an HTTP object in the object list. Yeah.
For submitting this, do you want it under the one you already graded, or do you want it under the other one?
Yeah, you can send it to this one. We'll do that other one another time. So
Okay.
just add this to your existing one. Now in that, let's just take a look at on this file, export objects. I can select that and do a save. And just for fun, I'm going to save it in my same little lab here. It gives it an interesting file name, .crl. It shows me the object here. I could always right-click follow the object here. And I do see a little bit of information here, some digital certificate, high assurance. It looks like it's my certificate file. And if I do a follow that stream, I get some interesting information about that. It's a RIT certificate, looks like. Now, I'm not sure if I can do anything with that because I believe certificates are regenerated in different sessions. But this may be some evidence I could use because in this certificate session is an actual date and time of when this activity occurred. So if I can identify what happened in this session, I can use this as evidence of when it actually happened on this particular date and time. And as the defendant says, no, I was somewhere else, or I was doing something else at that time, I wasn't at that PC doing this traffic, you can pop this up and say, no, we know this traffic happened exactly at this time. Now, as a forensic analyst, you'd have to somehow be able to confirm that someone hasn't messed with the PC clock. Is this data coming from my PC, or is it coming from the server, and the server has saved the date and time of when it was transferring the data? One of the biggest things that hackers do, if they're in your system and they want to hide their tracks or avoid prosecution, first thing they do is figure out a way to change the clock on your system. So it appears that what they were doing or when the traffic was happened at a different time, and they have an alibi for that other time. So one of the most dangerous things you want to watch out for is somebody changing your clock, because not only can that help hide hackers, it also can mess up your other software, because a lot of software depends on an accurate clock. So some systems you change the clock and you get strange error messages all over the place. You change the clock back, and there's other messages that appear. So a hacker will be very careful if they want to cover their tracks to change the clock, do some nefarious activity, and then change it back, because that leaves the trail of what they were doing and when they were doing it. So that was one packet track capture. Let's take a look at some of those others, because some of those others I found them, thought they might be interesting for practice for you. Let's just take a look at a couple of them. I have one down here. Let's take a look at, I think this guy had a lot of helpful traffic. And it describes how to capture and export a lot of those other objects. Very helpful if you want to learn about security. Here he's showing how capturing various of those objects can be useful. Down here in the FTP part of it, I think he had a link to multiple data files. And here's a helpful one showing you how following that and then capturing it raw. Very helpful, showing you how that's all done. And I thought he gave a resource for capture files. Oh, maybe it was that other one. There was a ton of files available. Let's just take a look at this one. I'm going to go to this one. He had FTP capture, and I think he has a small FTP file in this first one. He's got actually two little practice files and a video to go with it if you have any trouble. And let's see that. Maybe I have to do the view FTP. There we go. I'm saving the FTP file, and I've already saved it. And then I go view the folder where I've saved it. And in there, there's a PCAP file. Now you will see newer PCAP files have an NG in there, but the regular PCAP, notice it will still associate with Wireshark. Double click on it, and Wireshark will open up that capture file. Now let's see what we have in there. Let's do our first, do they capture the login and transfer? Let's search for FTP, all by itself, enter, and we see interesting data here. Let's right click follow, and we'll get the text of the whole session there. Follow TCP stream, and up pops my login. I see their activity, the system they're logged into, an old Windows NT. Here's a transfer of what? A directory list. He's trying to access this file on the server, it looks like. He's denied. They're transferring a file down, a CSV file. So it looks like we're looking for a CSV file. Let's see what they have in that CSV file. Anything else they've transferred? Looks like they transferred several times. Let's see if that file ever gets across. It does say transfer complete, but then we see access denied. Let's see if that file was transferred. Remember how we find that? You can close this, come back to the filter, replace that with ftp-data, enter. Oh, I don't see any data came across. So in his stream, he was attempting to transfer. Nothing actually got transferred. And so the attempt to transfer, he got the access denied, and the data did not get across as far as I can tell. Even though it does say transfer starting, transfer complete, when I look for ftp-data, nothing shows up. So he was attempting to access files. That's what I can tell. That's what I'm, based on that stream that I've captured, I can see that they've unsuccessfully attempted to steal my database information. Now this, even though they didn't get the data, I can prove from this stream that they were attempting to. Let's take a look at that other, there's another FTP file at that site, FTP2. Let's take a look at that one. Double click on that one. Let's look at the FTP session there, FTP, enter. I can see right here, even without following it, that they attempted to transfer a PNG file, it looks like. Let's follow that to see that more clearly. They move to a directory. They store this image called 111.png. Oh, it looks like they're getting a text file as well. So there looks like there should be two data streams at two different ports that transferred the file. Let's see if we can carve out those files from the stream. Close this. And if I were doing forensic analysis, I would actually be storing this information in my forensic evidence folder as I found each piece. But since I'm just exploring that, finding out what they transferred, I can now search for ftp-data. This time I do see some data that actually was transferred. Right click, follow. Here's a directory list. That one's not terribly interesting, so close that one. Let's go back here to FTP Data. Follow a different stream. That first one was not interesting. Oh, look at that. It even gives me the name of the file it was saving. So I'm going to right click, follow that one. This one's looking a little interesting. And again, I see the header of the file indicates what type of data it was. I view that as hex dump. Just for fun, I see that those first 4 bytes tell me it's a PNG. Somewhere in here is probably the name of the file. Oh, maybe not. Sometimes, remember an image file, sometimes there's actually GPS data stored in the image of where that picture was taken. Or someone's trying to fake you out of where they say the picture was taken. I now change the show and save to raw, and now do save as. And I'm going to give it the name, since I saw in the transfer they gave it the name 111, I'm going to store it as that same name, 111.png. Remember that suffix is how Windows associates what to open it with. Close that. And now let's view my files there. And I see that it appears to be a valid file. There still may be data hidden in there. It may be making me think, oh, they just transferred this innocent file. I may be still hiding secrets to my company inside that file that my forensics investigator doesn't realize is hiding in there. Now, there's other ways to perhaps find that. Steganography is a pretty tough encryption to break, because you need to know how the steganography was done. Steganography is just a general term for how data is hidden with the image. You may be able to detect that something is in there by perhaps having a different copy of the same image and seeing, hey, the original isn't quite the same as what you sent. You could compare it and maybe see that there's something encrypted in there. But to actually get the data out, you need to know how it was encrypted. And just imagine if somebody has some like a famous picture that's all over the internet, and any time someone sees that, they see, oh yeah, they got that dancing baby picture again. We can ignore that. People could be hiding data in those pictures that you find all over the internet. They could be storing national secrets in that using steganography. So there you have it, a quick and easy practice. I'm hoping you'll find this is easy, but after you've done this once already, getting to know Wireshark and how quickly you can find the data streams. Notice that was stream number 3. There was one more stream. I thought I saw one more stream there. If I look for FTP data, further down, I thought there was more. There's a manual.txt. Let's see what shows up in that stream. Let's follow that one. Looks like it's a very short file. Nothing terribly interesting. Looks like HTML. Well, what is it? Almost JSON data, I think. Maybe some secret password to something. Don't know what that is, but they stored that. If I go back to the original FTP, let's see what they were doing with that. They retrieved a manual.txt. All right, nothing super interesting, but it is an artifact. So in a forensics, I would document what the file was that I found. As I retrieve the data, I would store it probably with the same names that were used when it was transferred, and then keep notes of how this was all done, and of course have the original FTP, all your data files stored and a checksum set documented as well. So if anyone analyzes this, they would first check that it has the same checksum as you claim it has, so they know someone hasn't messed with the data, planted evidence, or modified the evidence to make the defendant look innocent or guilty. So there you have another little practice, just adding to that Wireshark FTP, give you a kind of an easy practice for today in network security. Forensics is a big part of security. You have to figure out what was being done. How do we protect against it next time? How did they get in? And if you're the one transferring, how did they get my secrets? Well, you used open insecure FTP. All right, have a great weekend. Fire off any questions. Email, I'll try to get back to you on that. I am stopping the recording.